I'm here to talk about acoustic blood oxygen level detection, or BOLD imaging. Evaluating blood oxygen saturation levels is incredibly important in a clinical environment. Now, when you think of blood oxygen saturation, you're probably thinking of pulse oximetry, or maybe an Apple Watch. However, there's an ever-growing need in order to monitor blood oxygen saturation regionally within specific tissue. For example, what part of your brain is being activated when you're performing a certain task? During pregnancy, is sufficient oxygenated blood being transferred to the growing fetus? In cancer, can we assess tumor hypoxia? These applications require very specialized tools that are more sophisticated. One of these examples is BOLD fMRI imaging. This is the gold standard in blood oxygen level detection. The way that BOLD fMRI works is it uses the magnetic properties of hemoglobin and distinguishes them when they're bound or dissociated from hemoglobin. One of the problems with BOLD fMRI is that it has poor sensitivity, it's very costly, very bulky, and it requires very long acquisition times. Therefore, we need better ways that are faster, cheaper, and more cost-effective in order to improve on BOLD imaging. Our idea is to utilize sound waves. Instead of fMRI, can you listen inside the body? Can you hear what's going on in the blood? It seems like a radical idea, but we actually think it's achievable using ultrasound imaging. Ultrasound imaging utilizes high-frequency sound waves to see inside of the body. However, ultrasound alone is not capable of determining blood oxygen levels. In order to solve this problem, what we have done is generated very tiny, small microbubbles that are comprised of hemoglobin shell. These particles are so small they can circulate within the body, and in an ultrasound field, the gas core is going to expand rapidly and contract rapidly. So these particles are vibrating, and they're displacing fluid. That generates sound that an ultrasound scanner can then visualize. Now, importantly, when these bubbles are oscillating, they're generating what are called harmonics. These are sound waves with frequencies at intervals of the fundamental. And essentially, these bubbles are singing. Importantly, when oxygen binds to hemoglobin bubbles, the properties of the bubble will change, and then the bubble will start to sing a different tune. What we are trying to accomplish in our lab, our main goal, is to try to correlate these songs that the bubbles are singing into blood oxygen concentrations. Now, this is an idea that's been nucleated here at UT Dallas that we think is going to revolutionize the field of medical imaging. And it's thanks to the hard work of the graduate and undergraduate students in the
Thank you.
department. Thank you.